So my name's Simon Flood. I'm an HPC system administrator at the University of Cambridge in the UK, but I'm also a SUSE knowledge partner, which I guess is probably why I've been allowed to present this talk. So I'm very grateful to SUSE for allowing me to be here at SUSECON and to have an opportunity to present to you guys. So now I'm like, oh, it's going to be. So what we're going to look at is briefly kind of what is OpenStack and why SUSE OpenStack Cloud. Obviously, we're here at SUSECON. Software and hardware requirements, setting up the administration server, and we'll look into what is an administration server, and then obviously deploying OpenStack nodes and services so you can actually use it. This is kind of a getting started. So you know, OpenStack's not much good if you haven't actually got anything running. So we're going to look at launching a basic instance. A little bit of troubleshooting in relation to getting started. So this isn't Adam and Vincent's, you know, troubleshooting session. I think they're doing a session tomorrow on that. Summary, and then also as a further information slide. So first, a disclaimer. I am not by any means an OpenStack expert. You know, having worked through some of this stuff and then thinking that actually a presentation for SUSECON might be of interest. You know, I've learned stuff about OpenStack that I didn't know, but I'm definitely not an expert. And I'm wearing a shirt. I'm a SUSE knowledge partner, but I'm not an employee. I work for the University of Cambridge. The knowledge partner thing is basically I'm one of the guys that hangs out in the discussion forums. So if you've ever visited forums.suse.com, there's me and several other people who hang out there. We try and answer questions. Obviously, that's an unpaid support resource. You've got SRs and things for support, but we know people who can then help. So either we find out the answer, post it back, or someone from SUSE might then come in and step in. But we're at SUSECON, so it doesn't matter. There are experts and there are SUSE experts here, and there's one sitting in here as well. So what is OpenStack? The headline is it's open source software for creating private and public clouds. That's what the OpenStack.org website says. Private and public. But from a sort of a beginner's point of view, or someone coming to OpenStack and you're looking at it, it's also, when you start looking in more details, it's a collection of very confusingly named projects, which are also called services. And there's about 60 of them at the moment. Things like Horizon, Neutron, Nova. I mean, they make, no, even when you get into OpenStack, they don't actually make any sense. There's no correlation between the name and between what it actually does.
Except for ironic.
Yeah, which is, that must have been named by a Brit, I think. And then the other thing about OpenStack is there's a new code release every 6 months, which has a challenge in an enterprise, obviously. Do you want to keep chopping and changing your code? So this is an architecture diagram. This is on the OpenStack website. This is for the Kilo release, which is one before Liberty, which is what SUSE OpenStack Cloud 6 is based on. And it's now 2 before Newton, which is what the next release, version 7, is going to be based on. They don't seem to have updated their diagrams. But basically, I don't expect you to be able to read all of this, but it gives you an idea that there's various different components, projects that all interact with our APIs. Horizon as a dashboard. We've got Ironic, we've got Heat, we've got Keystone. I mean, there's all storagey, compute stuff here, and they all basically interact with each other. And if you're coming at OpenStack from you don't know what it is. You sort of think, well, it's like every other open source. I can install my OS and then I can go and grab the source code and get it all up and running. That's usually where at the first stage that everybody fails, because it's kind of like they try that and it's like, they end up with no hair, or they've gone grey, and it's kind of like, whoa, and then they run away from OpenStack screaming, get locked up. So which is where, something like SUSE OpenStack Cloud comes in, because they're kind of hiding that from you. You don't need to know how everything interacts because they're dealing with that for you. So I mentioned Kilo and Liberty and Newton. So these are all, again, kind of random names. You know, OpenStack likes random things, it seems. But
random, they're named after towns.
Well,
near the
yeah,
conference.
yes.
So there is some logic.
There is some. There's a bit more logic with the release names. Yeah, yeah. Yeah, I'm going to get onto something at the very end on this one. So basically, these are all the OpenStack releases. It's a very sort of new thing, 2010. You know, it's only like 6 years ago that this all sort of started. And there's been basically every 6 months, give or take, there's been a release. And then basically in 2012, this is when it kind of things got slightly interesting, because in April you had the Essex release, and in August 2012, SUSE Cloud, the very first product, and it was called SUSE Cloud, got released based on Essex. And then a year later, we'd already moved on a couple of releases. SUSE Cloud 2 was released based on Grizzly. And then you can see 2014, we had SUSE Cloud 3 in August. So we actually had a couple of releases in 2014. In July 2015, we had the SUSE OpenStack Cloud 5. So that's when it got renamed, and they stuck OpenStack in there because it was helped sell it, you know. And then 2016, so March this year, we had SUSE OpenStack Cloud 6 based on Liberty. We've still had a couple of releases of OpenStack since then, Mitaka and Newton, and we're hearing this week, you know, that SUSE OpenStack Cloud 7 probably due in December. Now, the big bugbear I have with this, I mean, you know, the names aren't offensive or anything like that. The only thing I question is why they named the October 2016 release as Newton when you have a component, a service in OpenStack called Neutron. You know, there's scope for confusion, you know.
It's not a native language.
Well, it's just, yeah, it's, hello. I think they're released. Sorry, the question was how long the SUSE OpenStack releases are maintained for by SUSE. I think it's about a year, is it, or so?
We're doing a yearly release cycle of the code, so it is in full support for a year, and a new version will come out after a year. But then there's 2 years life cycle beyond that, so you get a total of 3 years on a single code base if you choose to remain on that code base. But importantly, from 6 to 7, so we're on 6, we're releasing 7 soon, we've solved the problem of disruptive upgrades. So you can automatically update from version 6 to version 7, and the virtual machines in your cloud won't show any reaction. So there'll be non-destructive upgrade paths. So we're hoping that will help people keep up with the release.
Yeah, I mean, that's always been, you know, upgrades between releases has always been a problem with OpenStack. I mean, certainly the earlier versions are kind of, you know, you don't touch them with a barge pole now. There's things that you really shouldn't be using the really old original releases. And there was a slide in I think it was Alan Clark and Joseph George's sort of OpenStack session the other day where they were showing sort of the uptake of, you know, people had installed Essex back in the day, and, you know, over time they've sort of come off of Essex and they've now moving on. So now we're seeing traction with some of the later versions now being used, but certainly it's with the later releases that sort of upgrades are kind of starting to be, I guess, be thought about in a bit. Although with OpenStack, you know, it's a release every 6 months, and they're kind of upgrades between OpenStack releases, so not the SUSE stuff, but just OpenStack is like, yeah, they can handle from like release Liberty to Mitaka. They can go from N to N+1. The trick is actually what SUSE are doing is they're effectively skipping an OpenStack release in between, and now throwing in the added complication of actually, well, you know, starting with OpenStack Cloud 6, you can actually upgrade to the next OpenStack Cloud release, so that'll be 7, but that's already moved on to OpenStack releases. So there's additional complication for SUSE to work out to actually but that's their problem. They're handling that for you to, you know.
Importantly, we are using the concept of backporting within the product line as well. So the version we miss, if there are things which customers need, we then backport it into our version as an update, very much like the model with Linux.
Yeah, it's the same with backporting fixes into SLES or whatever.
The application layer should be abstracted away from the OpenStack layer. So the fixes for enhancements in OpenStack should go in underneath and not be visible as an application. Definitely.
Okay. Have I just gone? Oh, yeah, that's fine. I've gone too far back. There we go. So why would you want to go with SUSE OpenStack Cloud? OpenStack is open source software, so you could just download it, build it yourself. You could, go and get another distribution. But there's a few reasons why you might want to consider SUSE OpenStack Cloud. SUSE was a founding member and a platinum sponsor of the foundation. That's kind of a good thing. It's good to have a company who are actually involved with the OpenStack project. SUSE, as seems to be the case with quite a few different things, as we've heard with CFFS for SUSE Enterprise Storage, SUSE were the first to launch, an OpenStack product based on OpenStack. So that's, I think that they get credit for that. Something of more practical use, they do support a wide range of hypervisors. They're the only company at the moment who are kind of, you've got KVM, Xen, and then you've got things like Microsoft Hyper-V, VMware vSphere, and also ZVM for power. And I guess, it's just, some people might not think this, but I kind of think if you're able to just install SUSE Linux Enterprise Server, then I think installing SUSE OpenStack Cloud, certainly getting it up and running, the starting point, the admin server is just as easy. It's not, it's not difficult. You don't have to, you're not involved with installing lots of packages by hand or building from source code or, jumping through some hoops. Obviously, you kind of need to know what you're doing and what you're expecting and stuff, but I kind of like SLES and how you install it, and if you want to, well, we'll get on to, I'll cover that in the next few slides. So I'll come back to that. So what are you actually getting when you get SUSE OpenStack Cloud 6? So this is version 6, so I'm not talking about version 7, the later one. So this is based on Liberty, as we said earlier. So you get all the kind of the projects and stuff, the basic projects that are part of Liberty, but you also get a few extra things which are sort of what they term technology previews and are unsupported. So you get, there's a few sort of projects. You get Ironic, which is bare metal provisioning. So that's a preview there. So you have to basically enable that yourself. It's not a project that gets, or a service, whichever you want to call it, that's provisioned through the dashboard. Sahara, which is things like Hadoop type stuff, and there's Trove for databases. But you also get some, like there's a Docker driver in Nova, which I'll touch upon again in a bit, and a few other things. And then the important thing is it's an add-on. It's an extension to SUSE Linux Enterprise Server 12 SP1. So as you can imagine, with the next release, release 7, that will be based on SP2, which was obviously announced beginning of the week. And the other thing is it integrates with SUSE Enterprise Storage 2.1, and I'm going to guess that will be bumped up for the next, next cloud release. I would hope it was. Yeah. Would it work now with SES 3 as a question?
You can make it work, but it's an engineering.
Yeah. Okay. And this is an image that I took out of the documentation, but I tweaked it slightly because I didn't like the original one. But basically, what you have is you install an admin node. That's basically SLES with a few extras, and then you're using that to actually deploy one of 3 nodes. So you might deploy a control node, a compute node or a storage node, and we'll look at what those do. But basically, there you have this one admin node, and it's basically, or admin server. They seem to use the term node and server interchangeably, and you're using that to deploy your actual OpenStack nodes, and it's the OpenStack nodes that do all the work. But your admin node is just a SLES server with a few extras. It's not running OpenStack. It's not part of OpenStack. It's just your admin server. The one thing that IT people, in my experience, are not very good at is reading manuals, reading documentation, whether it's for deploying software or whether it's for your video recorder or whatever. You just, oh yeah, I'll get it out of the box, plug it in, switch it on, and it works. Oh, no, it doesn't. Well, actually, with video recorders and stuff, it probably will, and you can figure out why it doesn't. In my experience with OpenStack, or with SUSE OpenStack Cloud, you really do want to read the manual, or at least some of it. There's a deployment guide. There is some really useful information in there, like the default network configuration. So in terms of this presentation, and like the idea was to set up a development network, it's really a good idea if you know which network it wants and expects, because then you can give it that. If you don't give it that, then you have to go and hack a whole load of files, and it's, life's too short, and you might as well just, give it what it wants, and then surprisingly, it's quite happy. So my development environment, currently it's a workstation. It's a Dell Precision T5500. I'm an HPC sysadmin, and this is one of our GPU compute nodes from our GPU compute cluster. So it's a reasonable spec. It's got 2 quad-core CPUs. It's got 24 gig of RAM, and you are going to need. I've just been in a hands-on OpenStack HA session. I think they've got Dell XPS 15 laptops with 32 gig of RAM. So they're saying if I wanted to mirror what I was doing in the lab, I would need at least 20 gig in a machine. So I'm using 24, and that's fine. It's got a load of storage. That's not so important. It's running OpenSUSE Leap 42.1, and I'm using VirtualBox for all of this. And the other important thing is it's actually acting as an NTP server for a particular network, 192.168.1240. That I got from the deployment guide. I know that's an important network to have, and that will come up again. Now, originally I was going to be using 4 Dell Optiplex desktops, which would have worked perfectly fine, as long as they've got, a decent amount of memory each. They were 64-bit. They'd have run SLES 12, no problems. But obviously, 4 machines under my desk, it's not ideal, and you'd need a router as well, perhaps. And I did try it with my MacBook. I've got the original sort of white polycarbonate MacBook that has 4 gig of RAM, and you can get it to 8. And it worked, but it was damn slow. So this originally was going to be a practical demo, and then actually Simon did a webinar, and you had a few issues. So
it's actually using a cloud,
right.
Data center.
Yeah, but it was when you had your few issues, and I was finding it was slow. Yeah, so
I convinced you, did I?
Yeah, but I was hoping, I'm supposed to be getting a new work laptop, and I was hoping that I would have it in time for this, but Dell have been stupid. But it's going to be one of the Dell XPS 15s with 32 gig of RAM and stuff, so that'll be nice. And I actually have another one of these boxes. Someone was throwing out a box that had, essentially it was the same sort of thing with 4 gig of RAM in, and I fired it up at work and couldn't understand what was wrong with it, and I stuck in 32 gig of RAM, and it's perfectly fine. So that's that's my home desktop. So in terms of what you need SUSE Linux Enterprise Server 12 SP1, the AMD 64 Intel 64. So basically the 64-bit release. You only need the DVD1, whether that's as an ISO or as a physical media, doesn't matter. If you're virtualizing, then the ISO is fine. You also need DVD1 of the SUSE OpenStack Cloud 6 media. And then a slightly odd thing, you'll also need, if you don't have access to updates, you'll also need an updated Python request file for the which is part of the SLES 12 SP1 updates. It needs to be either version 2.5.2 or a later version. And you can get all of these from the download site. You can get a 60-day trial of SUSE OpenStack Cloud and SLES. And that's, I thought that was worth putting in there, because what I found with some other distributions is that you might be able to get like the operating system, but then you'd actually have to register, jump through hoops to actually get hold of the OpenStack software. Like there's a particular coloured Linux I'm thinking of. You actually have to get your Linux OS up and running to then subscribe to some channels to then be able to get to the OpenStack stuff. Whereas this, you can take these ISOs and this updated file offline and get it all up and running on a completely isolated network. You don't have to subscribe to, patch downloads to get this all up and running. So I think that's kind of a good thing to have. So yeah, this updated file, basically what will happen is if you try and deploy Keystone or Cinder, which are the control and storage services, you'll get this, hasn't quite come out here, but you kind of get red text on a pinkish background, and one of them, you can read all that text, and eventually somewhere in there it says you need a Python request file such and such. The other one is a bit more cryptic, but it's the same thing. So if you have an issue with Keystone or Cinder, chances are you've probably forgotten to update the Python request file. And how to put that into place will come along in a minute.
Might I be cheeky and take the opportunity to suggest if you are going to look at this technology, please register for the free patches and patch your machine, because if you run into problems, at least you know you're on the latest code base to then get us to help you.
Yeah, I mean, part of the documentation, there's 5 or 6 different ways of dealing with updated patches as you're actually installing it. I've been a little bit naughty/stupid, lazy possibly. Well, I don't have an SMT server, I don't have SUSE Manager all up and running for this. So I found another way, and that's, but I just thought it's worth mentioning. So in terms of hardware requirements, in terms of your actual servers or nodes, your virtual machines, whichever it is, what you can get away with is an admin server with a gig of RAM, but your control node, your compute node, your storage node will need at least 1.25 gig of RAM in order for it to install. If it's got less, it just won't work. However, in reality, you really probably want to go with what SUSE recommend, which is you want at least 2 gig of RAM in your admin server, in your control node, probably 2 gig in your storage node. And if your compute node, basically, if you've got machines, or you're doing it virtual on a desktop or a laptop, and you've got enough RAM, then really, if you want to spin up, if there's certain instances you want to spin up that have certain memory requirements, then obviously your compute node or compute nodes need to have that amount of memory to be able to allocate to a machine. So it's no good going, well, I'll spin up a compute node with 2 gig of RAM, fake RAM or real RAM if it's a physical machine, and then say, well, I want to deploy a 4 gig instance to it. It's not going to work. So you need to make sure that that's matching. With hard disks are a lot easier in a virtual world, because you can basically pretend that you have the storage. You just over provision them, or thin provision as they call it. But you're kind of going to want to aim at about 50 gig a server or node, and then you can give it more. But you can always just say, oh, here, have a 200 gig disk or set of disks, thin provision it. It will only take up what it needs on workstation disk. In terms of networking, a single network card is fine, but you want to attach it to a special, host-only network that you might have set up. And the important thing is to make sure that the network is above the hard disk in terms of the boot order, because you're going to basically fire up your admin server, get it all installed, and then boot up your nodes, and they're going to do a Pixie boot against your admin server. So you need to make sure that the Pixie boot stuff is going to work first. In terms of deploying OpenStack, you'll find that when you look at other options, you know, do some reading about deploying OpenStack, you'll find that there's various different methods that keep coming up. And two of the most common ones I keep seeing is something called OOO, which is OpenStack on OpenStack. And there's PackStack. Now, OOO, what that actually does is it creates what they call an undercloud, which is basically that's a cloud that is used for deploying your real cloud, your overcloud. So what you're actually doing is, it's to a certain extent, you're deploying OpenStack twice. You're deploying your undercloud, which is OpenStack, and then you're using that to then deploy another cloud, which is your real cloud. If you then, with this particular software, if you then want to upgrade your OpenStack system, you'd upgrade your undercloud to then go and upgrade your overcloud. Well, I don't understand that. It's like, why would you handle two different clouds? It can be complicated enough dealing with one cloud. So why you would deploy a cloud to deploy another cloud is just, yeah, I think that's a bit mad, but anyway. And PackStack is basically using Puppet modules to, you have your servers that are installed with an OS, and you use Puppet to then deploy OpenStack to those servers. So they're the kind of ways that you, I mean, there are other ways. Mirantis have another way, and you know, there's, you know, lots of different ways.
Mirantis recently pulled out and laid off their team.
Okay. So anyway, with SUSE OpenStack Cloud, you basically set up an admin server. It's an admin server. It runs SLES, and it has a couple of extra things, Chef and Crowbar. Chef is kind of a Puppet type thing for deploying and sort of a configuration management. Crowbar is a Dell thing. It does the sort of heavy lifting, put stuff into Chef. But it's a Linux server. It doesn't have OpenStack on it. It's not an OpenStack server. It's just a SLES box with a few extras. So it's like any other SLES box that you might have already deployed. So how do you install the admin server? This is kind of a run through of the kind of things that you're going to be, you know, when you fire up an install, and so this is kind of a manual install. SLES 12 SP1, you want to give it a static IP address, and importantly, you want to give it a particular static IP address. You want to make sure it's 192.168.124.10, and it's got a host name of admin.something. You know, give it a fully qualified name. It doesn't have to be cloud.example.com, but call it admin something. You also want to make sure it's got a default IP version for gateway, 192.168.124.1. These are kind of assumed. You don't have to do this, but if you don't do this, you're going to have to edit some Ruby files, and yeah. At least for, you know, in terms of like getting this up and running, having to play with it, I'd say stick with the defaults. Obviously, if you're deploying it for real, I mean, you probably have spoken to SUSE. You might have a proof of concept set up. You might have some consulting. You know, you're probably going to have some sort of support from SUSE, and they're going to come and help you out. I didn't bother registering because, you know, I was doing this all isolated. I've added on the SUSE OpenStack Cloud product. This is just in terms of ButterFS. You know, I didn't want to split my hard disk into separate areas, so I just combined the home as well. Excuse me. Another thing is you want to set up NTP. So you want to, so in this case, I said the NTP address is the router. The router is the IP address on the actual local workstation, and that was what I'd set up earlier. I skinned down the software that was getting installed, so I removed all the GUI stuff. I don't bother on a server, and some of the other bits, and I just made sure that the meta package cloud admin is the SUSE OpenStack Cloud. Disable the firewall. It doesn't like having a firewall enabled, and I wasn't too bothered about that. It's a private network anyway. And then what the documentation says is, oh, you know, if you're using local repositories, then you should set your repositories to custom in this Crowbar configuration overview screen. But in my experience, that doesn't actually make any difference. You set it, and you can go back in there later and check it, and it's still got it to what it was originally. So I don't actually know whether that makes any difference. So what the documentation then says to do is create some repos for the product media. So you're effectively, because this was a virtual machine, I've attached the SLES 12 SP1 CD, DVD to like a CD drive, DVD drive, and then attached the SUSE OpenStack Cloud to another DVD drive. So they're both there, available. And then I've just rsynced, mounted each disk in turn, and then rsynced them to a particular path on the admin node, depending on which one I'm doing. These are in the slides, which are available for download, and they're in the documentation as well. And then we get on to pull and update repositories. So the SUSE documentation kind of says, well, you can offer updated packages via, the actual source for SLES and SUSE OpenStack Cloud. You can offer it via an SMTP server, SMT server. Sorry, it's not a mail server. You can have a remote one. You could have SUSE Manager. You could mount your repos from somewhere else. You could synchronize your repos from somewhere else. Or you can manually synchronize them from media. Well, they offered me all these options, and I went, nah, I'll do something different. So what I did was basically create fake repos on the admin server. So it's not currently supported, but I'm going to have a chat with SUSE about whether that might be an option. So basically what you're ending up doing is creating the directory structure on your admin server, copying the media or the relevant bits of the media into that directory, and then you're doing a create repo against that location. And then that way you can actually create your updates and copy this updated file in there, and then it's happy. So that's the SLES stuff. This is the SUSE OpenStack Cloud stuff, which is a bit more straightforward. There's no hacking to do as such. There was an oddity that really puzzled me for a while. Basically what happens is you create these repos, and the install will use those for installing the nodes, but also within the OpenStack dashboard you can set the repos through what they call a Barclamp. And I couldn't understand why I couldn't enable the SLES pull and update repos, and it turns out there was something very odd in this particular file that was stopping that happening. So as soon as I commented that out, so it matched everything else, it worked a treat. But that, yeah, was a bit of a head scratcher. Obviously, if you're using SMT, whether that's locally or remote, or whether you're using SUSE Manager or you're doing one of the other things that SUSE said, then you don't have to do all of that. But I was trying to do this in a very self-contained environment. So yeah. And then before you do the next step, you want to check that time is in synchronization. So you want to make sure that the ntp.conf file is referencing your 124.1 time server, and you want to check that hostname -f is a fully qualified name, so it should return admin or whatever, and there should be one line in your host file for that particular IP address. There should be 124.10 with something on it, and then you're ready to install SUSE Cloud. So this is a single command line that you type in. And hopefully, if everything's worked, it will come back and says, yep, you're all done. You can go to a website now and go and look at a UI, a web UI. If you're doing this at the console of the admin server, you can just run that. If you're doing it through RNSSH, then you would need to run, use screen or something to actually capture the instance in case that gets interrupted, because you don't want to launch this and then find that you've dropped the connection and things are broken because of it. So,
did you experiment with the web installer?
I haven't. No, I see there is a web installer. You can do this. There's a chef something or other in it, I think.
Yeah. So you can choose rather than use the manual. The manual's great, it works fine. But if you'd like to use a web installer, you have to do an extra couple of commands to start up about cheap too.
Yeah.
Then log it into the site, but it's all instructed.
Yeah, there is. I mean, yeah, there is. If you don't like the CLI, then it looks. Yeah, the web. There is a web interface to do this, and it does look a little bit prettier, but.
It does the same.
Yeah.
If you run into it.
Yeah. If it doesn't work, then you can rerun it. If it kind of works, but you then. So, I suppose it's worth saying that at this point, it's kind of set in stone what you've done. So if it works, it's kind of that's working. Don't then go and break it. If you then, for whatever reason, need to or want to go and change something, and you want to rerun it, that's where it starts getting interesting, and you might actually have to then. I think I remember doing something with Chef to kill something or other in order for it to rerun because it was kind of recognising the fact I'd run it and.
Well, it does drop a log file in saying you successfully installed, and you have to remove that.
Yeah.
Yeah. All those things are detailed in the error message.
Yeah, I think I was using Chef knife and killing the admin or something. It was like, oh, you've already done it, and therefore, oh yeah. Yeah, I didn't know anything about Chef. I started learning about Chef. So you've got your admin server. So we have no OpenStack running at this point, but we now have our deployment box ready to go. Installing the admin server is actually pretty quick. You know, if you've got access to, I mean, there's some things there that are particular to being in a virtual environment on a desktop. You know, all the private stuff and the hacking around with the repos. If you're doing it on real kit, then I don't think it's going to take any time at all. It's you know, in my experience, it doesn't take that long to deploy SLES, and if you're doing like a minimal install of SLES, it really doesn't take any time at all. So all you're really doing is installing SLES on a box. You're copying the product directories, so you've got those available. You're either copying the packages and having repos available, or maybe you're already pointing at an SMT server or SUSE Manager or something. If that's all running, if you've already got that in your infrastructure, then that will save an awful lot of time. Yeah. I mean, I think if you're dealing with physical boxes that are of a reasonable spec and stuff, then it won't take that long at all. If you're dealing with slightly under spec machines or you're doing it virtual, then you know you're competing for resources and that will slow it down. But I know of OpenStack installs that have gone on for days/weeks. This is not a days/weeks thing. So yeah, I won't say any more for.
I don't have a signature, I can tell you.
Yes, we might embarrass other people as well. Yeah. So you've done your admin server, you run the install-suse cloud, and at that point you can now hit this magic URL, which you can't see up there, but it's the 192.168.124.10 address that's been in earlier slides. And what you get is this lovely dashboard that doesn't really tell you a lot. And normally you would get, I think all you get is this. You actually get a green, this is supposed to be, it's green, there's yellow, it's a slight difference. You get a lovely SUSE green dot next to something that says SW-unknown, and that's your admin server. Now the first thing I do is rename that so it says admin, because you're going to see an awful lot of unknowns otherwise. And then these nodes here are basically my compute and control nodes. So I've kind of cheated at this point and just fired up a whole load of VMs ready to be deployed. And the thing you'll notice again, well, no, you can't read it very well. These are MAC addresses. So what it is D, and then you've got the MAC address broken down into pairs, which if you're dealing, so the way I tend to do it is I deploy my OpenStack, the admin server, go into the dashboard, then I fire up one node. Because at that point, I don't need to know the MAC address of it, but I know that I fired up one will appear in here with its number, I can then handle that, deal with that, give it a name, something that applies, start configuring it, then I can fire up another one, then another MAC address is going to turn up here, and I just do them one at a time. So that way I don't have to spend time of going into my virtual machine, checking what the MAC address is going to be assigned to it, so I know which one is which, because you know you might have given more storage to your storage node, you might have given more memory to your compute node. So rather than having to work out which is which, I just fire one up at a time. You know, you're dealing with the same machine in my case, so it's just pressing buttons and refreshing. And the username for this is, you can have a username and password of Crowbar. So it's username Crowbar, password Crowbar. This is all documented, and you can actually change those. It is documented how you can change the password. Which, if you're obviously dealing with a private, but if you're dealing with a slightly public network, you probably want to change them. You get that list of, if you boot up all your nodes, you get a long list. You might not want to have to edit them all by hand, one at a time. So what you can do is do a bulk edit, and then, you know, these are suggestions that I've used. I've named my admin node as admin, and then I've named my control node, storage node, compute node as control, storage 1, compute 1. I've tended to number the storage and compute nodes because you can have multiples of them. Yes, you can have 2 controller nodes, but in, you know, all the testing and stuff I've done playing around with, I've just had the 1 control node. But you can have 2 control nodes and use HA and stuff. So the slides, if you download the slides, you'll be able to actually zoom in and see this in a bit more detail. It'll make a bit more sense. And well, it's not actually that much better on this screen, so it's yeah, just washed it out. And in terms of deploying OpenStack services, what you have on the dashboard is, along the top here, you have something called Barclamps, and when you click on it, a little drop down comes down, and you have a choice of, I think it's all Chef and OpenStack, something like that. So I just deal with the OpenStack stuff. I've not had to do anything with the Chef stuff. And what this, you can see I've underlined something, but you can't see what it says, and I can't really. But I think it says something about create and apply these in the order that they're listed. So basically they're saying you have a list here, and what you don't want to be doing is, right, okay, well, I'm now going to apply this particular one, whichever it is. I think this one probably says heat. So you don't want to apply heat to a node until you've done everything above. But actually, it's not everything. You only need to do certain ones. There's a minimum set that you need to do to have something up and running.
There's some prerequisites where you need a database in the background to be able to build the services, things like that. So we help you walk through that process in the right stage.
Yeah, I mean, it's the one. This is the one. I haven't quite worked out how it could be. I mean, I know it can be improved, but sort of how it could be done. But it does sort of seem to me at the moment is, you know, in this process, you have to sort of go through these in order and kind of go, do I need it? Do I want it? Do I need it on every single one? And I sort of think maybe, and this isn't a SUSE thing, this is an OpenStack thing. There seems to be you have to, you know, and I think that's because these projects are all separate, yeah, and you know, I think they could probably generally make this easier. And I think maybe with Mitaka it might, or Newton, they might have made it easier. I can't remember. I thought I saw something somewhere about it being made easier, but I haven't seen a result yet.
There is some argument over containerization of control plane services.
Okay.
Which might make it easier to stand them up.
Right. Okay.
Maybe Crowbar could direct you, so if you make a choice to miss one out, then other ones black out because they're now not available or something.
I mean, I don't want to make it like a Windows GUI because this isn't Windows and stuff. So there is a danger that you could make it too simple, and it's kind of like, well, you know, deploy the messaging server, right? Okay, done. Okay, next step, you know, click next, click next, click next, and you could be sitting there going next, 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 all type this, next, 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 type this, but yeah, it does strike me that okay, they've listed them in the right order, but it would be nice maybe if like some of these were grayed out because you hadn't actually done an earlier step or something. I wonder whether there's something that could be done to make it easier. But the idea is that you work your way down the list. You click the edit button if it's edit or create, depending on which, what it is. I think this is something like pacemaker, database, RabbitMQ. Pacemaker you don't need unless you're doing HA. You do need the database. Once you've got the database, you can do RabbitMQ. Once you've got RabbitMQ, you can then work your way down. But there are some here that you don't need to do. Some of the storage stuff, you can make a decision about what you want. The documentation does kind of cover, some of these are optional. It's not necessarily clear why you might, which ones, how you work your way through it. But this is the list of all the Barclamps. And the things that I've been assigning. So as I've worked my way down that list, I've configured the database and I've set my database server as a control server. So these names, control, storage one, are the names of my nodes. So this isn't a, I probably should have said control one, and then it's quite obvious that I've named my nodes. So I've just worked my way down, setting these things as I've gone. And then when it's come to Nova, to the compute option, you've got 6 different options here, where you're basically saying, I think the default for Nova is that they assume that you want to actually set your, they want your compute nodes to be Zen. So this is a SUSE decision. The default for compute is Zen, but you might want to use KVM. You might want, might be doing something with Hyper-V or ZVM or something. So they will have populated the Nova Compute Zen, but you can drag your node out of that and drag it back into something else. So there's a few here. So you've got Docker as a technology preview in version 6, and then there's QEMU, which they offer, but it's not supported. So you might think, well, why are they offering me something that's completely not supported? But that will become clear in a minute. But it's basically a case of working your way down and then applying them. And some of them will take, seconds to do, others will take a little bit longer where it kind of works out. So in terms of why QEMU, if you're using VirtualBox and you want to, you don't want to use Zen, you want to use KVM, you'll actually find that doing KVM under VirtualBox, it won't actually work. It'll look like it works. But then when you actually go to deploy an instance to one of your compute nodes, you'll be like, well, where's it gone? Why isn't it deploying? And what has happened is that the KVM bit isn't working quite properly under VirtualBox. So if for anything that you want to test as KVM, deploy it to QEMU instead, and it will work exactly the same as though it was KVM, and it will actually work. But if you pick KVM specifically and you're using VirtualBox, it won't work. And I've not tried this, but I believe if you're using KVM for your virtualization and you want to do KVM for your compute nodes, that you need to configure nested KVM on the actual KVM of the host. And I think that's true for AMD and Intel. So we've got this all up and running. Everything went well. It's all, great, hopefully. What you'll end up with is you'll have deployed the OpenStack, what they call Horizon, the OpenStack Dashboard as one of your last things. There are other things you can carry on doing, but the list I just had was kind of the minimum you need to get up and running with something. What you can then do is then hit the IP address of the node that had Horizon distributed to it. So it's probably the control node. So that's probably going to have an IP address of 192.168.124.81. So you would go to that. That gives you a website. You can log into that. Again, username, password of Crowbar, or you can use a username of admin. That will get you in, and you basically get presented with this, assuming everything's working, you get presented with this overview of this is what's kind of going on, and at that stage you won't even have any usage. This is just because I've had some previous usage. It will just give you a blank screen, we haven't done anything, but you can now use it. So what you probably want to do at this stage is you're probably keen to just sort of like, oh yeah, I want to get a node up and running. I want to prove that I've done something. So you can then click on. It's really hard to see actually what it is, but yeah, you'll be able to zoom in on this on a PDF. But you can then click on images, and you can then launch an image, and you have to configure a few things. You give it a name. And what you can do is, so there's a few different sources for images that you can actually use to launch an instance. The one that is really quite good, is great for testing, is something called Syros. It's really small, not only in the size of the file that you're downloading, but actually it's really small in terms of what it requires. So if you've set up a very small test environment, you've only got a compute node that has 2 gig of RAM, you haven't got much storage available, then Syros is great because you can actually get this image up and running. It uses the very small default m1.tiny, which is like, it has no memory requirements and it has no storage requirements really. It's essentially running on, I don't know what it runs on, nothing. So that will actually, at least, if you can get that up and running, at least things work. You can, obviously, we're here at the SUSE conference, so there's SLES 12 SP1, there's a juice image that you can use, and there's also OpenSUSE Leap 42.1, and I'm sure SP2 has just been released, and I'm sure a juice image will probably come along for that in the next few days or weeks. And in the OpenStack documentation, there's a whole list of other ones. If you happen to like particular other versions of Linux, then you can get images. Yes?
Does it include tools to create your own images?
Good question.
There is a tool we use in SUSE, SUSE Studio, if you've used that ever, to build SLES-based images. If you use other distributions or Windows, then you have to actually hand crank those images to then inject them into your image repository.
Yeah.
But we make it pretty simple with SUSEstudio.com. You just need to give us your email address, which you probably already got.
Yeah, if you've got a SUSE ID, or rather a Novell.com ID, so if you're already logging into the SUSE website, then you can log into SUSEstudio.com with the same credentials, and then.
It's a very versatile WYSIWYG. I do all my proof of concept work up there. I download. It actually gives you it builds an image according to what virtualization you want to put in. It'll put the SLE in it, the cloud in it, element into there as well, which is an open source
set of tools, yeah,
that needs to be used in your VM. And all those things, and it's very easy to do, and you can download it in a compressed archive file.
Yeah.
So it really is the simplest way possible of populating your.
Yeah, you can build your other one. You can run Windows in OpenStack if you want to, but you'd have to.
It runs fine on KVM actually.
Yeah, yeah. I mean, basically, SUSE will offer you the juice for, I think it's just SLES 12 and SP1, and I guess SP2 in the future. OpenSUSE, I think you can get a few other releases. I have built ones for like SLES 11 SP4 for a colleague. I did that through the SUSE Studio and got that running in here. So that was the same sort of thing, getting the cloud init tools in there, sort of a minimal install of SLES, and that worked fine. The one thing I will note, certainly, doesn't apply to Syros, as I say, that's got really minimum requirements. But in terms of SLES and OpenSUSE, the images that you can get, they have a requirement for 0.5 gig of RAM, which is, that's not a lot. But strangely, they also have a requirement for a minimum disk of 24 gig, which doesn't sound a lot. But the problem is that the disk requirement puts you into so you get different flavors pre-configured into OpenStack. So you can m1.tiny is like, it's got no requirement at all, and Syros is fine. Then there's m1.small, and I think that has a minimum disk of, is it 10 or 20 or something like that, but it's not enough for SLES. So then you go to, it's either m1.medium, I think it might be, or m1.large. But at that point, it then wants more cores and more memory. even though the SLES and OpenSUSE image doesn't need that, but you're trying to satisfy all the criteria. So in order to give it 24 gig of disk, you're going quite high up, but at that point you've probably used all the memory or all the CPUs that you allocated your compute node, which is kind of crazy. So what the slide on the right, if you're looking in the document in the PDF, I'm creating a specific M1.SUSE one that says, okay, give it half a gig of RAM, but just give it 24 gig of disk, one CPU, one core, and then that works perfectly fine, and then you're at least not wasting it so much.
The disk size is an inherited thing from Profess from the default file system now. You can change it to shrink that disk.
Right, okay.
Which is a technique I've used.
Oh, maybe.
Either way it's valid.
Yeah, maybe I should do that.
The different sizes of the machines you're running, they often talk about in cloud as t-shirt sizing.
Oh, yeah.
So that's how they use it.
Yeah, if you've got any familiarity with Amazon Web Services, then you know it's the same thing. You know, it's they might not call it M1.tiny and whatever, but they have their they have lots of different sizes, and yeah. My first experience with cloud was with AWS rather than with OpenStack. So that all of that will get you an image up and running. So you could, you know, there is a way within the OpenStack, within the Horizon dashboard, you can then connect to your instance there and then in the browser. So with the Syros one, you know, they have a particular username and whatever, you can log in and do that. Obviously, what you probably want to do is access it from something else, like maybe just from your workstation. So you'd need to edit the default security group. You need to allow, you probably want to allow ping, so you can actually ping the thing and make sure it's working. You want to allow SSH, but you also need to provide an external gateway with a particular IP address, because that's assumed on a particular VLAN. So I'm just making a note of that. I'm not going to go through how you do all that. Because I just want to sort of like, oh, you know, here we are, get it up and running. So we've created our image, and now we're actually going to launch our instance. So we're launching Syros here, and this is, we're just basically using a very small test image, getting it up and running, and then hopefully what you'll end up with is you can then connect to your virtual console, and you'll see that Syros has actually booted. And the last thing it's saying here is log in as a particular user with a default password, and then you get a login prompt and you can log in, and that's your first OpenStack instance up and running. So along the way of getting to this stage, I had quite a few problems. Some of them obviously self-caused, you know, shooting yourself in the foot and all that business. The first thing that I was struggling with is that I was doing all this and I was firing up all my nodes, but none of them ever appeared in the dashboard. You know, I had the admin server up and running, I had the dashboard, and it didn't really matter what I did, none of my nodes actually appeared. And the cause of that was that I didn't have time synchronization. I particularly saw this on my MacBook, and because that did some very strange stuff with time. But even on my desktop initially. So that's why I made the host server offer time to that particular network. So even though I'm not a time server for my local network or anything, it's just my own local workstation, I made sure that the private network was getting time, and then that fixed it. But how did I identify it? Well, in particular log files. So you get so basically what happens is when you boot a node, it uses a kind of a cut down version of SLES, which they call Sledgehammer. And that boots and it provisions a node, and gets a minimal install, and basically it creates a log file with the MAC address of that host and the domain, so like .example.com, and you can look in there and it will basically be moaning about the time and stuff, and it's, oh, okay, I need to fix time, and you eventually work out what to do, and you get that sorted. Another thing you find is that you've got your nodes, and then you start deploying things to them, and you're like, well, hang on a minute, why am I getting this big red message? So that in the case of the Python request stuff, one of the screens told me what it was eventually, it was buried there. Another screen, it didn't, although it turned out obviously to be the same issue. So you check the varlog zipper.log file, and that was showing some error messages, and buried in there again, it's giving you a clue as to what's going on. Another thing, as I mentioned, you're deploying instances, but they're not going to a particular node. So I had a test of a Zen node and a KVM node, and I'm like, well, why is everything going to the Zen? And then when I'd filled that up, why is it not going to KVM? And I just didn't understand it. And then, yeah, again, one of the log files, which I should have made a note on there, was indicating that something wasn't quite. There was something very odd about the KVM node, and then yeah, it's yeah, it was something very strange. It was something very strange, and it's kind of whatever. And then you start, go to your support tool of choice, Google, and you start going, well, hang on, and then yeah, I think that I was going round and round in houses, trying to find that one.
You get reasonable at that level. You get reasonable logging from Crowbar, so varlog/Crowbar.
Yeah.
Log is a reasonable tool there.
Yeah.
Some of the logging when you're actually running in cloud can be a bit challenging because the logs reside on different elements of your cloud, and we haven't yet got in the OpenStack community a consolidated cloud. Yeah, they do tend to have a sort of a, there's a log file for Nova, there's a log file for this, there's a log file, so all different places, yeah. Across your different virtual machines on the different hypervisors. Yeah. Which is a challenge, and we're working hard to improve that. Yeah. Upstream as well as with SUSE.
Yeah. I mean,
but at this level, Crowbar will help you.
Yeah. Yeah. I mean, and the good thing actually is that if you have your admin server, if you have a node, what you'll find is that on the node you get a set of log files, but actually on your admin server the same log files are there because they share a bit sort of a fake disk or whatever you want to call it. So you don't have to necessarily go off to all your nodes to check things. If you do need to access your node, then what you can do is SSH as root into your admin server node, and then you can jump from there to any of your other nodes. So if you've got a compute node, you just SSH to, provided you know what the IP address is, you first SSH into your admin server and then use that as a jump host to get to your compute node or your storage node. So, and there's no password authentication, it's all done via private keys that have been set up via, the installation itself. So you haven't got to worry about all of that.
On that SSH, there's a nice little trick that you use. If you go in on the SSH to the admin node, and you want to know which server to then jump to, you use knife node list, I think. It lists out the names of the machines. It is MAC address based, but you can quickly work out which machine. Because you're in SSH, you can copy and paste that to then route into the actual node.
Okay,
it saves time and faffing about.
That's useful. Okay, thank you. So that's really the end, sort of the end of the session. It's certainly not the end of my journey with OpenStack, and hopefully it's not going to be the end of your journey with SUSE OpenStack Cloud either.